Hello guys, I hope you have already seen the previous two lectures of PYQ of JEE Mains 2024. So now I am continuing the third video of that PYQ series. So in that the first question is the difference in energy between the actual structure and the lowest energy resonance structure for the given compound is. Suppose benzene is there, then the benzene actual structure is this and the resonance structure is like that. So the what is the energy difference between these structure is called as what? So we know the resonating structure is the more stable than the actual structure. Suppose this is the energy profile diagram. The energy of that actual structure of benzene is this and the energy of the resonance structure of benzene is this. Then the question is, what is the difference between these two energies called as what? The difference between energies is called as resonating energy. So here the options are mesomeric energy, ionization energy, hyperconjugation energy and resonance energy. So the fourth question is the resonance energy. So the fourth question is right. So now the next question. The uranium ion which is not involved in the bromination of aniline. So how we can carry out the bromination of aniline? First the aniline is this, and bromination is carried out by bromine water. So how it help, how it is goes? So in bromination of ions, first we draw all the resonating structure in bromination of ions, intermediate structure. So first let's suppose it is the electrophilic substitution reaction. Let's suppose this one pair goes and this attack on that electrophile. So what happens? Double bond NH2 plus this double bond H Br positive on nitrogen. So now the next resonating structure is this double bond goes to there, this goes to there, and this goes to there. So NH2 double bond very H HBr, their positive charge. This is the orthodirecting. In bromination of aniline is orthodirecting as well as paradirecting. So in the paradirecting, what happens? This lone pair goes to there, this and this attack on bromine. So what happens? Here Br comes, double bond NH2, here double bond, here positive charge on nitrogen, and the another resonating structure of that is this double bond goes to there and this goes to there. So NH2 Br, here double bond, here positive charge. So now the four options were given. Among these, which is not a involved resonating structure in bromination of aniline. So these are the four options we are given. Among these, which is not involved in the above resonating structure, this focus on this. This is involved in here. This one is here. This is the meta directing, means this is not involved. This is involved here. So correct option is C, which is uranium ion is not allowed in the bromination of aniline. C option is correct. Now the next question. The next question is match the following. So in the first column, these four are given. This we have to match with the metal are given in the second column. First metal is rhodium, second is cobalt, third is iron, and fourth is titanium. So in that compound, which metal is present? So in the Ziegler-Natta catalyst comes from this polymer. In that catalyst, which metal is involved? Titanium. In blood pigment hemoglobin is present, and you know in hemoglobin iron is present. And in Wilkin catalyst, this is the homogeneous. I hope you have studied about the homogeneous catalysis. In that Wilkinson catalyst is used. Here the rhodium metal is used, and in vitamin B12 cobalt means for first is C, second is D, third is A, and fourth is B. So here the option we are given is third. So the third option is correct. Now the next question. The question is type of amino acids obtained by the hydrolysis of proteins. Means what is protein? Proteins are the polymers of amino acid. But which type of amino acid? Alpha, beta, gamma, delta. Here the four options were here. First option is gamma, second is delta, third is beta, and fourth is alpha. We know the proteins are the polymers of alpha amino acids. Here the correct option is alpha amino acids. So the proteins are the polymers of alpha amino acids. So the correct option is D. Now the next question. The interaction between the pi bond and lone pair of electron present on an adjacent atom is responsible for. Means suppose this is the pi bond and this is the lone pair. The interaction between this pi bond and this lone pair is responsible for. Means what happen between these two electron pairs? First option is resonance effect, second is electronic effect, third is inductive effect, and fourth is hyperconjugation. This is the this lone pair goes to there, this bond pair goes to there. Means what we call it this resonance effect or mesomeric effect. But here the option given is resonance effect. So in first option resonance effect. So first option is correct of this question. So now the next question. In that question, the two statements were given. The question is the given below two statements. One is labeled as assertion A and the second is reason R. Means the in the first statement, the assertion is given. What is assertion? Aryl halides cannot be prepared by replacement of hydroxyl group of phenol by halogen atom. Means what? Aryl halides. Suppose this one is the one of the aryl halides. Suppose chlorine cannot be prepared by the replacement of hydroxyl group of phenol. Can we prepare this one by the replacement of this OH in the phenol by chlorine? No, this is not any reaction. We can't do this reaction, and the reason is phenol react with halogen acids violently. But we can prepare phenol by aryl halides by reacting with NH at high temperature and high pressure. It gives phenol. This reaction is happened, but not this reaction is. Reverse reaction is not feasible. So the second statement is phenol reacts with halogen acids violent. Means statement says that phenols reacts with acids violently. Means this not happen reaction. So this is incorrect statement, and the first statement is aryl halides cannot be prepared by reacting phenols with the halogen acids. So the first statement is true. Means first statement is true and second is wrong. So the here option is third option is A is true and B is false. So the here second option is correct. Now the next question. The question is identify product A and product B. Here the reactions is given that cyclohexene is here is reacted with chlorine gas in first in presence of light and in second in presence of carbon tetrachloride as solvent. So the product A and product B. So the question is identify product A and product B. In presence of light, what happens? It forms chlorine breaks down into radical. So radical is formed, and if this react with cyclohexane or we can say double bond, so here which radical is more stable? If radical is here or here, this radical will be more stabilized by the allylic. This double bond means we call it that radical as allylic radical. So allylic radical is more stable. So this radical is combined with chlorine radical. So what will form? This, or here also chlorine can be added. So in presence of light, this product is formed. But in presence of CCl4 or solvent, this called CCl carbon tetrachloride as a solvent. So what will happen here? If we react with chlorine gas in presence of CCl4, what will happen? Here is the addition of chlorine on the double bond as a trans. Here the addition of chlorine in the double bond. This is the anti-addition, and the addition of halogen on the alkene is called as electrophilic addition. So here the stereochemistry is not involved. So therefore we are adding both chlorine and this. So what are the A and B product? This one is the A, this one is the B. So the correct option is B. In the B option, A is given that and B is given that. So here the correct option is B. Now the next question. So the next question is the major product P formed in the following reaction is the reactant is this, reagent is used as concentrated hydrochloric acid. So what will be the reaction? So if you react this compound with HBr, HBr is in excess, though this will react with this ether and also with alkene. So how it will be react with ether bond? Here first it will take acidic proton. So what will happen? OH, CH2, CH3. Here positive charge is come. If we break this bond, then what will happen? Positive charge is carbocation is formed on sp2 hybridized carbon atom. And if we break this bond, this one carbocation is comes at sp3 hybridized. So which one is more stable? This carbocation is more stable. Then what will happen? OH plus CH2 CH3, and this carbocation will accept will forming a bond with Br minus ion. So what about the alkene? Here in the alkene, it reaction is happen simultaneously with ether and as well as alkene. So in alkene, what will happen? It will takes H plus ion. So carbocation is formed at this is the benzylic carbocation which is highly stable. So what will happen? Suppose this reaction is happen and here OH is formed. What will CH plus CH3 and here Br minus is there, it will react. So what will be the final product? OH here CH Br and here CH3. So this is the final product. Sorry. This H plus will be accepted by this pi bond. So carbocation is formed at which is the benzylic carbocation is highly stable, and this finally react with Br minus, and this will form the final product. So here the correct option is 4. So this is the D option. This is the correct. Now the next question is the final product formed in the following multi-step reaction is. Here the one multi-step reaction is given. Here the first reagent is acidic hydrolysis. Second is chromium trioxide. Third is NH2, NH2 in presence of pH base and heating. So, what will happen in presence of acid with double bond or alkene? What will happen? Here the addition of water on double bond. So here will be OH and H added. Here the carbocation is more stable, though therefore negative part, that is OH, is added here, and here H is added. So now the CrO3. CrO3 is the oxidizing reagent. So this will oxidize secondary alcohol to ketone. So what will be the product? So now the ketone. So now NH2, NH2 KOH in terms of heat. So NH2, NH2OH and KOH called as, this type of reaction is called as Wolff-Kishner reaction, which convert aldehyde or ketone to alkane. So what will be the product? If you want to study detail Wolff-Kishner reaction, I will study in detail Wolff-Kishner reaction in another video. So what will be the final product? This will be the final product. So the D option is correct of that question. Now the next question. The question is the number of compounds among the following which contain sulfur as a heteroatom. So here the six compounds we are given. We have to identify in that compound which has a sulfur as a heteroatom. The first compound is a furan. You know the structure of furan. So furan is that. Here the not sulfur atom. So this is not answer. Thiophene. What about thiophene? So in furan there is no sulfur heteroatom. In thiophene has this type of structure. Here the sulfur is as a heteroatom. In pyridine nitrogen is as a heteroatom. In pyrrole also nitrogen as a heteroatom. In the cysteine has a structure CH COOH NH2. Here CH2SH. So here also sulfur is one of the heteroatom. And in the last one is triosine. Triosine has this type of structure. Here no sulfur atom is there. So how many compounds are there which has a sulfur as a heteroatom? This one and this one. So here answer is 2. 2 has among these, 2 are the compound which has a sulfur as a heteroatom. So now the next question is, from the compounds given below, the number of compounds which give positive Fehling test. You know the Fehling test is used to identify the aliphatic aldehyde. Only aliphatic aldehyde, not aromatic aldehyde or not for ketone. So the compounds were given. One is the benzaldehyde. Is the benzaldehyde used? Benzaldehyde is aromatic aldehyde, therefore Fehling test is not used for that. Second is the acetaldehyde. Acetaldehyde CH3C double bond O. Yes, this is the aliphatic aldehyde, so the Fehling state can be identified to acetaldehyde. Next is acetone. For acetone, this is the ketone, therefore Fehling state is also not used for acetone. Now the acetophenone. What is the structure of acetophenone? Benzene C double bond O CH3. This is also aromatic ketone. Therefore here also not use the Fehling step to identify the compound. And next is the methanol. Methanol. This is the alcohol. Therefore this Fehling step is not applicable for methanol also. Now the 4-nitrobenzaldehyde. This is also the aromatic. And last one is the cyclohexane. This is also not aromatic aldehyde. This is the normal cyclohexane. So Fehling state is not used for that also. And last one is the carbaldehyde. And the last one is the cyclohexane carbaldehyde. What is the structure of cyclohexane carbaldehyde? This is the confusion question. So here cyclohexane carbaldehyde is C double bond OH This is the aliphatic aldehyde. Here is no aromatic or not ketone is not there. Therefore, failing test can be used for that also. So, how many compounds are there which can be identified the failing test? This one and this one. So, your answer will should be two. So, now the next. In that question, the reaction is given that here the double bond H CH3 CH3 EH. Here first ozone, second one is zinc plus H2 and the product. You know, ozone plus zinc plus H2 is called as reductive ozonolysis. There are two types of ozonolysis. One is the oxidative ozonolysis and one is the reductive ozonolysis. So this reaction is a reductive ozonolysis. So the what is the question? Consider the given reaction. The total number of oxygen atoms present per a molecule of the product P. So first, what will be the product in the ozonolysis? We know the what will be the product. This for according by trick, this double bond will break, and what will be the product? Double bond OH. Here also same double bond OH CH. This compound is acetaldehyde, and both are the same. So the question is how many number of oxygen atom per molecule. So here are the two molecules and two oxygen. So the per molecule is one oxygen. One oxygen is per molecule. So your answer should be one. So the next question. So thank you guys. Now I will stop here. If you have any doubt, comment, write in comment. I will discuss in the next video. So thank you.